start looking at multiplying integers. Now, if we have 2 plus 2, we can think about that as a walk on the number line. Here's my little creature, character, whatever you will, and if I add 2, that person takes a little walk to 2 to the right on the number line. If I add 2 more, the person is at 4. So I have twice 2, and I see if remembering that multiplication is successive addition, if I have 2 times 2, it equals 4. So of course you all know that the product of any positive number times any positive number is positive. Let's look, for example, here. If I have 2 times 10, suppose I gave you $10, or 10 guilders in this case, you would have 10. If I gave you another 10, you would be $20 richer and have 20. So positive times positive is positive. Makes sense. Let's sneak up on what happens when we try to multiply negative integers. So we're starting here at the number line, and if we have minus 2, it means I walk backwards 2. If I have another minus 2, starting from minus 2, it means I've walked backwards 4, and I'm sitting at minus 4. So since I have 2 minus 2's, I could say that 2 times a minus 2 leaves my creature sitting at minus 4. So I notice that if I multiply a positive times a negative, and I've put the negative in brackets so that you can distinguish what I mean, because otherwise I would have the dot for the multiplication right next to a minus, and it might look a little unusual. So to make absolutely sure that you understand what I'm talking about, I put the brackets in. And the brackets are very useful for that in mathematical operations. At any rate, what we've seen here is if we have minus 2 times, or 2 times minus 2, the result is negative. And if I reverse it, because remember, the order in which you perform a multiplication doesn't matter, so minus 2 times a plus 2 is also minus 4. Or, if I wanted to, I could abstract this where a and b are any numbers. If I have minus a times plus b, or for that matter, plus a minus b, I would get minus ab. The result would be negative. So I could infer the product of any negative number times any positive number is going to be negative. Let's look at another case. What about negative times negative? Now, this takes a little more wrapping your brain around, but we're going to use money to do it. Suppose I took away a loan. In other words, you owe me $10, and I wipe the loan out. I say, you don't owe me any more money. Well, a way of thinking that is you would be, or I would be, $10 ahead. Suppose I did it again. Then I would be $20 ahead. So in a sense, if I take away, minus 2, two $10 loans minus $10, the answer would be 20, or 20 gulden, or dollars, or whatever have you. That was just some pictures of currency I happened to have found on the internet. So the generalization we can make here is that a negative times a negative is a positive. Let's review that. So positive times positive is positive, exactly what we've been doing up to this point. Negative times negative is positive. So notice that if the two signs that of the numbers you're multiplying are the same, be it negative or positive, the result is positive. So if the product of the same signed integers, be it negative or positive, as I said, the result is going to be positive. On the other hand, if the signs of the two things I multiply are opposite to each other, if the signs are different, the product is going to be negative. Let's look at a few examples. Suppose I have minus 2 times minus 3 times minus 4. Now remember, it doesn't matter which order we do the multiplications, so that we could group them in twos, and then once we have the result for the first two, then we multiply by the last one. So if I group this, minus 2 times a minus 3, remember those two signs are the same, so I get plus 6, multiply that by minus 4, and the result is minus 24 because I have a positive times a negative. Let's look at something a little bit more interesting. If I have minus 2 times the quantity 3 minus 5 and 7 times the quantity minus 2 minus 4, let's see what we would get here. First minus 2, and then I need to do the math. Remember, we need to do the math inside the brackets first. Then we can go on. 7 minus 2 minus 4 is minus 6. Then minus 2 times minus 2 is plus 4. 7 times minus 6, because the signs are opposite there, is minus 42. So minus plus 4 minus 42 gives me a negative 38 as my final result. Let's go to looking at exponents. Now remember that exponents are shorthand for a repeated multiplication. So a to the 5th power is a times itself 5 times. And just to remind you of some terminology, the a, the number you're multiplying, is called the base, and the number of times you multiply it, which is written a little bit smaller and up to the top, is called the exponent. I have minus 2 raised to the 3rd power, or minus 2 cubed. Let's see what I've got. It's minus 2 times minus 2 times minus 2, and just as we did before, we could take these in groups of 2 and multiply them together. Minus 2 times minus 2, 2 negatives, a positive plus 4, multiply that by minus 2, and the answer is negative 8. Let's look at another one. We have negative 3 to the 4th power. That's minus 3 times itself 4 times. So if we group them minus 3 times minus 3 and minus 3 that way, I get plus 9 there, negative times negative, plus 9 there. 9 times 9 is 81. So let's see if we can generalize. Here we've represented minus 2 to the 4th equals 16, and minus 2 cubed equals minus 8. So in both cases our base is negative, but in one case the exponent is even, and we get a positive result. In the other case, the exponent is odd, and we get a negative result. Now, this is true generally because if things are even, you can group them in twos, and so if you can group two negatives together in twos, they can be positive. But if you have an odd power, as you see here, you're going to have 2 grouped in twos, which is going to be positive, and then multiplied by one more negative, which is negative. So, again, if your exponent is even and your base is negative, the result will be positive. If your base is negative and your exponent is odd, the result's going to be negative. Let's see if we can make this into a rule. For evaluating signed integers raised to any power, a positive integer raised to any power at all is positive. A negative integer raised to an even power is positive, and a negative integer raised to an odd power, for the reasons I explained, is always going to be negative. Now we need to be careful here, because if we have the quantity minus 2 squared, that's not the same as minus 2 squared. Because in the first case, because you have brackets around it, you're including the minus sign. In the second case, with no brackets, the squared works only on the 2 and not on the minus. So minus 2, the quantity squared, is going to be plus 4. Minus 2 squared is minus 4. You need to be careful and watch for this notation when you raise these things to a power. Be careful, I say. Minus 2 squared, because the whole thing is in parentheses, the whole thing gets raised to the power. If you have minus a 2 squared, just the number is raised to the power and the result remains negative. Let's look now at dividing integers. Remember that division is related directly to multiplication, and in fact, it follows the same rules for signed numbers. Positive divided by positive is positive, as we have seen up to this point. Negative divided by negative is also positive. Again, with the same sign, the result is positive. The quotient of the same side integers is positive. Positive divided by negative is negative, and negative divided by positive is negative. In other words, when the signs are different, the result is negative. So the quotient of differently signed integers is negative. So the rule for dividing any two signed integers, like signs result in a positive answer, and unlike signs result in a negative quotient. To multiply or divide signed integers, like signs are positive, unlike signs result in negative values. Now remember that we can represent division any one of 3 different ways. So 12 divided by 3 is 4. Everything is positive. Minus 55 divided by 5 is plus 11. 12 divided by minus 3 is minus 4. So there are all of the rules represented as we show 3 different ways to represent division. Well, now I say, let's try a few examples. In this example, we have 36 plus 6 times a minus 2 divided by minus 3 times 4. You may notice at the left we have someone climbing some steps. And what I wanted to indicate here is this is another example in which you can't solve it all at once or at one step. You need to do it little by little. So the first thing we're going to do is multiply 6 by minus 2, and I get minus 12. Then we'll take the number we're dividing by, minus 3 times 4, and get minus 12. So we see plus 36 plus a minus 12. If I think about the number line, I walk 36 to the right, walk back 12, I'll get 24. That's divided by minus 12. So I'm almost there. I have 24 divided by minus 12. Positive divided by negative is going to give me a negative result. So my answer to this problem is minus 2. Here's yet another one where we have 3 numbers divided by 3 other numbers. We'll take 3 times minus 4, and that gives me minus 12 times 12. Then we'll take 6 times minus 6. That gives me minus 36. I'm part of the way there. The 12 times 12 gives me minus 144. Now I have a minus 36 times a minus 2. And so I have minus 144, negative times negative is positive, divided by 72. And my result is minus 2, negative because the number I'm dividing is negative. We're going to continue using the rules we've seen so far, solving equations using multiplication and division of integers. The same rule applies: do unto one side of an equation that which you would do unto the other. Now we need to get x by itself, and I see that x is multiplied by negative 8. I need to then divide both sides by minus 8. So to get x by itself, I divide minus 8x by minus 8 and the 32 by minus 8. When I do this, I find that my solution to the equation is x equals minus 4. Minus 23z is equal to minus 92. To solve for z, I need to get that by itself. I see it's multiplied by minus 23. To get z by itself, I need to divide both sides by 23. When I do this, minus 92 divided by minus 23, negative divided by negative, gives me a positive result, and my answer to this equation is z is equal to 4. Let's try something a little bit different. Here we have our unknown raised to a power. X squared is equal to 16. And I remember that I need to do the same thing on both sides of the equation. I need to ask myself the question, what times itself is equal to 16? 4 times 4 is equal to 16, so perhaps x is equal to 4. It also turns out, if I think carefully about it, minus 4 times minus 4 is equal to 16. So to solve for x, I take the square root of both sides, but I need to be careful because the square root of 16 can be either 4 or minus 4. Remember that 4 times 4 is 16. Minus 4 times minus 4 is also 16. And you'll see that funny symbol often in math where you have a plus on top stuck to a minus on the bottom. That's read plus or minus, meaning that either plus 4 or minus 4 is a valid solution to the equation. And in fact, equations where you have something to a second power will be covered in great detail in later algebra classes. I'm just mentioning it here, and we're dealing only with the simplest solutions. But it's not unusual when you have equations with exponents greater than 1, there may be more than one valid solution. Let's look at another example. This is a bit more complicated. We have x squared equal to 26,896. So we need to do the same thing to both sides of the equation. To get x by itself, we need to take the square root. This is a fairly complicated square root, and the best way to do it is to try to sneak up on it. 200 times 200, when I multiply it, is going to be 40,000. 150 times 150 is 22,500. So we know it's somewhere in between those, and now we have to experiment. If I take 160 times 160, I get 25,600, not quite enough. 165 times 165 is 27,255. And I finally try 164 times 164, and I find that that looks like what I'm looking for, 26,896. So I can finally say, when I've solved the equation by taking the square root of both sides, that x is equal to plus or minus 164. Because if I square plus 164, I'll get what I started with. If I square minus 164, I will also get what I started with. One more case that we might want to look at: what about x squared equals minus 16? If I take the square root of both sides, I have to ask myself, is there some number that I can multiply by itself that would give me a negative number? Now, if we think about it, if the number is positive, positive times positive, like 4 times 4 is 16. Minus 4 times minus 4 is also plus 16. So are there numbers that I can multiply by themselves that will give me a negative number? And the answer, in a sense, is no and yes. As far as we're concerned in this class, the answer is no. But mathematicians have asked this question and have extended mathematics into a realm called imaginary numbers. Numbers that, when you multiply them by themselves, give you negative results. At first it was thought that imaginary numbers were useless, just a figment of the mathematician's imagination trying to push the ideas of math beyond what we do every day. And then it turned out that engineers were able to use imaginary numbers in solving fairly complex problems involving motion that's repetitive, oscillatory motion, how a pendulum sways, or how your car moves going over a bump. Turned out imaginary numbers, initially a mathematical abstraction, were very useful. And in future math classes, you will be dealing with imaginary numbers, but you can relax, not here. Now let's look at some word problems using multiplication and division of integers. I particularly like this problem because I'm in it. And in fact, parachuting would be something I'd really like to try, but at this point it's just a dream for me. But let's look at the problem. Dan parachutes from an airplane traveling at 8,000 feet. He falls for 2 minutes, moving downward at a rate of 1,345 feet per minute, and a sudden updraft carries him upward for 3 minutes at a rate of 256 feet per minute. How far above the ground is he then? And we're given a formula that the distance is equal to velocity times time. Let's look for the information given in this problem. We see that I fall downward for 2 minutes, moving at the rate of 1,345 feet. The updraft carries me upward for 3 minutes at a rate of 256 feet, and it asks how far above the ground am I after all of this happens. Let's look at the diagram. Here I am falling at 1,345 feet per minute, and it's given that I start at 8,000 feet. So here's where I start. I fall for 2 minutes at 1,345 feet per minute. Down I go. Then I move upward for 3 minutes at 256 feet per minute. Up I go there. And what I'd like to know is, how far have I fallen? So the distance is equal to the velocity times the time. That's the formula we need to use. How far above the ground am I at the end of that 5 minutes? To analyze this, we take the distance I start, add the distance I fall, add the distance I rise to get the distance above the ground at the end. We'll use distance as velocity times time to find how high above the ground I am after 2 minutes and then after the next 3 minutes. And we're going to use down as negative and up as positive. So when I'm moving downward, we're going to be subtracting. When I'm moving upward, we're going to be adding. So we start at 8,000 feet, and then I add minus 1,345 feet per minute for 2 minutes. And notice that I've added that as a negative velocity because I'm going down. Then I add back the 256 feet per minute for 3 minutes because now I'm going up. When we do the math, we start at 8,000 feet. I fall 2,470 feet, which is what I get by multiplying minus 1,345 by 2. Then I go back up 265 feet per minute for 3 minutes. So those are all the distances. When I add those up, I find after 5 minutes, I'm 6,298 feet above the ground.